Okay, so now we're going to go back to the first page of your notes because I feel like now we actually have enough background to know what the heck I'm talking about. So I'm going to talk to you about something called a gas discharge tube. We're going to get to look at some of these in class, or maybe already have. And what happens in this is you have some gas, so xenon or helium or something like that, and you add energy to it in the form of electricity in this case, and that excites those electrons. So it causes them to do that jumping up. Like if we look up here, it would be like an electron here could jump up to there when we add that electricity to it. But like we said, electrons like to fall back to a lower energy state. And when they do that, they emit energy in the form typically of electromagnetic radiation, which if it's at a certain energy level, we can see it with our eyes, right? If it falls into the visible light spectrum. Do you see how it all connects together? Whew, so much to keep in mind. Well, for hydrogen gas, when we do this, we can take the light that emits. It's going to actually look, I don't know why it looks blue here. Typically it's pink, so it's kind of a bad drawing of it here. But that pink light then goes through a prism. Prism just slows down the different wavelengths and different speeds, and so we get to see 4 distinct lines from hydrogen. Okay, we call it. There's a red, a blue, green, so you'll actually hopefully get to see these at some point in class. Well, we noticed it was always I wasn't there. Okay, Planck and all those guys noticed that it was always the same 4 lines for hydrogen. Now, if you think about it, it's a little bit weird because hydrogen has 1 electron, but remember, in a sample of hydrogen, there's like a bazillion atoms, and so that 1 electron, well, take it times a bazillion, and it just has 4 different available jumps, is what that would mean. Okay, so in hydrogen, there must be 4 jumps that we can see with our eye. Now, there's others, but these are the 4 that happen to fall in the visible spectrum. And so using Planck's work, so that's why I put this stuff up here. So Planck's work, remember, he's the one that gave us the idea of quantized, like there's only certain energy levels available. Okay, we can see it's not all the colors, right? It's not continuous. There's just certain colors available. And then also using the idea of Einstein, oh, that's not highlighter, Miss Cunningham, that was pen. Einstein over here telling us that, hey, you know what? Light can act like a wave. That's why we can talk about it like frequency and wavelength, but it can also act like a particle, which is why we can talk about it only having certain energy levels available. He was able to kind of combine that together, and that's why we ended up with the Bohr model that puts electron energies with these photons, these particles of light from Einstein emission. And so we're seeing red photons and these bluish and purple and whatever that would be. Okay, so according to the Bohr model, using all of these ideas of quantize and photons and all of that, he said that, hey, you know what? Electrons aren't just hanging out at any old energy level. They can only circle the nucleus, I'm going to maybe say at instead of in, at specific energies. It says at specific energies. I'm sure it's really hard to read, which we would call, because we know this, for a photon, we'd call that a quanta. Okay, so electron, we know that photons, light is quantized, but Bohr is saying, hey, you know what? So are the electrons. They're quantized too. And because they're saying it's quantized, our definition of that would mean that there's not energy levels between that. There's no option here. There's no option there. There's this step and this step and this step and this step. There's nothing in between. Okay, so Bohr model is the first time we'd see that something quantized besides light. Now electrons are quantized as well. And guys, if you would go into study science, you'll see quanta, the idea of like quantized or quantum computing. The idea of quanta, of specific energy levels or specific levels being allowed, is widespread. It occurs often in science. We just happen to be seeing it here with photons and very closely connected then to electrons being quantized.